So to collaborate effectively, we think you have to have these elements. And, oh, this doesn't work very well. There's supposed to be 3 circles here. I don't know. Anyways, these 3 circles represent the OEM, the Tier 1, and the semiconductor industry. This is a model that we use. It's in practice today at Infineon. It's actually in practice in the automotive industry where car makers around the world collaborate with semiconductor suppliers around key technologies. It's not new. It's not specific to Infineon. It's not new to even the domestics. Actually, I think one of the biggest creators of this or instigators was BMW. BMW really felt that they couldn't just go through a Tier 1 to a Tier 2 semiconductor supplier. They needed to bring them to the table, collaborate in this type of model. One of the ideal collaboration scenarios, we've titled this virtual vertical integration. It's, as you can see, we're talking about specifically about power electronics for vehicle electrification. This is a chart created by Infineon. You will see sometimes people from GM present this slide with their letterhead, but we created this based on our assessment of what the market is from a competency level and how it could effectively work for a group of companies to be successful. And we basically break the pieces of the business down to the semiconductors, the modules, sub-assemblies. So for us, that's the power module, maybe with the gate card or the drivers, gate drivers on it, the inverter design itself, and then up at the hybrid system level. And you can see that no one entity has the full competency. The only caveat here is you could put Toyota here, because Toyota is not virtually vertically integrated. It's pretty much vertically integrated. And aside for their power semiconductor knowledge, which is probably not a full circle, it's a half circle, they're almost this way. This is also, you could say, from a business practice, the old General Motors of the 50s, or maybe the Fords. But in today's market, to get this level of collaboration, which is ideal, you really have to, or to get this level of integration, you have to collaborate across the supply chain. Yeah, so this is an interesting picture that looks at kind of the business side of what are the criteria when companies collaborate, and what are our different options. And if you look at this vertical integration, again, the Toyota of today, I would say relative to power electronics and automotive, or the GM of the 50s and the Ford of the 50s, you can go through all the criteria. I don't need to read them all, but you can see that there's some benefit here. We moved to this traditional model, which is used across most products on an automotive platform. And of course, you can see there's a lot of negative here, but I'd say this is used mostly on the products that you don't need to collaborate. For example, carpet. There isn't so much exclusivity needed in carpet. In power electronics, there might be, but in carpet, there isn't. So what evolved then was this, what they call specified, where the OEM would actually reach into the supply chain and tell their customers or their supplier's supplier what product they would supply to their customer, which ultimately came to the top of the food chain. And they would start specifying the pieces. So they don't do it everywhere. So they don't do it in carpets. They don't necessarily do it in seats or a lot of sheet metal part, but in some technology parts, this is the way that many of the automakers try to operate. There are a few that operate up here at this virtual vertical integration, which really is, in our opinion, the best of all worlds. So some real-world examples. I have 2. One is about optimizing the system. You can see here on this side the value goes up as the complexity goes out. If you don't optimize, we have these power modules that will be discovered thousands of years from now. And you also have the risk that you don't have the best vehicle performance. You have the risk that you don't meet your CAFE requirements. You have the risk you can't sell cars. And if you're GM and Chrysler, who are in good shape now, but a serious issue away from more serious issues, you can see that you can't afford not to collaborate to really optimize the system. So some examples of what this could be is, if you look at these, you can probably tell from the battery who this might be, but you can look at this type of system collaboration where you start with vehicle level targets. And in the old days, or in the non-power electronics days, what would happen is the OEM would send a spec to a Tier 1, and the Tier 1 would extract a paragraph or a line out and send it to us. So I need a part that does that. That still happens in a lot of places. In power electronics, though, that doesn't happen with a lot of the OEMs. They actually bring us and the Tier 1s into the discussion about what the vehicle level requirements are. So what are the mile per gallon requirements for this vehicle platform? And how are you going to help me achieve them? And again, the old, less mature way is to say, I need 20% improvement on miles per gallon. I need a 30% reduction in cost. So just take 30% off your price. That's how we get there on the cost side. The way it happens now when you collaborate is you have situations where an OEM might actually agree to pay a Tier 2 a 20% premium over his last generation if they can understand that they can lower their system costs by their target, whatever that percent might be. So it's very mature. It's not widely used. It's, in my experience, limited really to power electronics and embedded control for powertrain. But it is active in the industry. So this basically just trickles down to our world. And as I said, they achieve some significant improvement. The other major challenge that they have is this mismatch of roadmaps. So this happens constantly where you have an OEM, he has a model or an architecture plan of several different generations of an electric drive architecture. You have a Tier 2 semiconductor person who's planning different technologies that don't match. The OEM has the opportunity to wait to generation Y or maybe to generation Z to get silicon carbide. But some of these OEMs can't wait. Their pressure on them to be successful in their business, to meet CAFE requirements, to meet cost targets are such that they cannot wait to do this. So with a mismatch of this sort, we do have options. Now, when I go back to my slide on collaboration, how I talked about those 6 characteristics. If you have partners with the right, the willingness to deal with those 6 characteristics, to live them, you can collaborate with car makers and Tier 1s to really to advance your technology roadmap. So it may not seem like such a big deal, but if you're a semiconductor supplier who has GaN on your roadmap in 2028, and you have a customer that needs it in 2018, or maybe that's too far, but 2020, we have a process, and this is a intentionally very vague chart, but it shows that if you take requirements, you do some detail analysis, you can actually build some parts, do some modified development validation, and then make a decision to really accelerate the roadmap. This may not seem so big if you're not necessarily in the industry, but this is usually as far as things go when roadmaps don't line up. We just do some, yes sir?
Cost savings on that, what kind of cost savings do you get from just doing run-through, let's say, on the design, and how much buy-in you get on the design?
We've seen in the low 20s. I mean, 20% could. You're talking about if you just collaborate. Yeah, you can achieve 20%. I mean, there's so many variables. You could achieve 5%, but we've seen as much as in the low 20s.
Yeah, it's a good model.
A lot of people what?
Similar models. I don't know if you know about Barry Ball. His ideas about incremental fitness models.
No.
Like this, we kind of get buy-in on design first before you cut any metal.
Right. Yeah. What's and I'll stress it again just because it's fairly important. If you take the GaN or the silicon carbide discussion, at this point you have a semiconductor company who is actually building a part that was not going to be built. We weren't even going to do the development part for another 5 years. But in the right collaboration model with the right partners, we might pull that ahead. It's a very subtle, and I know that the quantum guys understand what that means, but it can have a significant impact. So, 2 minutes. Collaborating is important. The question that I have is, and this is more of a question of the audience, is as I look at the smart grid, and now I realize it's smarter than I thought it was, and I'm new to the smart grid. And I like it because they use terms like peaky load, which is pretty cool. where are there opportunities for semiconductor companies to collaborate in this industry with the players in this industry? And I don't know if anybody has any ideas. I know we've had some discussion last night. Maybe we need more wine. That seemed to move the discussion along. Any ideas? Not a trick question, it's actually a question.
I'm not